Hi everyone, I'm Tessie Kim, assistant professor at the Texas A&M University Kingsville. Thank you for giving me opportunity to share my research work and in the KICS Winter Conference. Today I'm gonna talk about an overview of the cybersecurity for power and energy system. Yeah, this is outline. So I'm gonna introduce the what is a cyber physical power and energy system and some cyber attack history targeting DES system, and you can also share the I'm gonna share the some energy sector security trend and also security challenging in the will be given as a by providing one example. After that, I'm gonna review and introduce some security research approaches for the power and energy system. So including some grid rule and standard before we study the cybersecurity for power and energy system, we need to know, understand the nations or some specific regions, rules and standard. Also, we can just look at some example of the cyber system focus, industry control system, or operational technology security focus. And also, we're gonna look at some future threat focus, such as quantum computing attack. And conclusion will be followed. Okay, so what I'm working on is the next generation power and energy system contributes to creating a clean, sustainable, and secure world. So what is a power and energy system? You guys already know that. It is about research on the advanced battery energy storage system or renewable energy system, microgrids, smart grid, electric vehicle infrastructure like a fast charging system as well. So we're gonna just try to make efficient and safe, reliable, low cost, and intelligent the power and energy system. So basically saying that we're gonna generate power, transmit power, and distribute power. Also, we're gonna store the power. All things we will control the power, provide such a power to the world. It is a power and energy system. And then I'm gonna expect that the current power and energy system has been and can be further revolutionized as a result of the integrating advanced cyber physical system. So most of people already know that the cyber physical system concept and a little bit different IoT concept. Cyber physical system, we have full computational resources and network capability. In addition, using such a system, we gonna control the physical system. It is the controlling is also important part in the cyber physical system. So you can now look at this the cyber physical power and energy system. So we study the conventional physical system. Power electronics is a power device level or microgrid level, and power system we're gonna study the power flow control or optimization in the power system. And as you guys study the cyber system, including network and cloud, IoT, or AI, all things utilize the some computational high computational resources and the network. So luckily, we can now use energy IoT technology devices, right? So we can make some connection between physical system and cyber system so that we can advance the physical system because in the physical systems, the performance is constrained actually by the embedded system. We can also use some, for example, cloud system or edge network system to support or some service to the physical system. So another one, we cannot, sometimes we cannot use some cyber system support. So we are also preparing some onboard solution. So if network is available or some cyber system is available, we can also use some optimized method or any advanced technology we can use through the network. So studying such a stuff together is about cyber physical power and energy system research. So okay, this is a modern power infrastructure as you know that. Now we're gonna integrate lots of renewable energy system. So or many country has their own roadmap. Even USA, they by 2050 they're gonna increase the capacity of the renewable energy system by 60%. Other Europe, they already reached about the 60% something more. So this is what we know that. Another trend, big trend is electric vehicle, right? Company and a country, they have their own roadmap. So ultimately, all vehicle will be the ultimately it will be the electric vehicle, right? In addition to charge it, such a the electric car, we need some extreme fast charging infrastructure, which can provide, for example, 400 kilowatt. It's very large, right? So if you, for example, 10 electric car try to charge the to be charged simultaneously, it requires larger power in the very short region. So it is another huge load demand in the current and near future. We will see that. So such a new environment, including energy storage system, renewable energy system, and electric vehicle and charging infrastructure, change the some power system now. So the good thing is we can use such a renewable energy system or store the such energy, or sometimes we can sell, right? But the problem is we just rely on the inverter based distributed energy resources, which can which will cause reliability issue and resilience some issue. So for example, California, even Jeju Island, we experience some, oversupply from the, wind turbine system or solar pump system. You know, some a certain reason who need a more electric, who need electric power, for example, like extreme fast charging infrastructure, may experience, a power deficit. So such a situation will be very fast and change it very fast. So it will cause the reliability and resilience issue in the power infrastructure. So we need some situational awareness and the optimal control, so that we need some complex computing and communication. So luckily, and thanks to the advance of the ICT technology, now we can use it. We can further utilize it. Such an environment changing in the power system will cause some cyber attack. I can simply show that some cyber attack cases. In 2003, there was some software bug, in the alarm system, so that it made some blackout. It is some human error. Sometimes we consider it is an inside attack. And another one, very small event, smart meter was hacked by the employee, and also it is kind of some inside attack. And some big attack happened after 2011 in the history. Stuxnet attack target the SCADA system in the nuclear plant. So it hacked, corrupt some such a system. Another also very famous cybersecurity attack targeting power system is Ukraine power grid. So hacker switch off the Doris substation using the some malware. So this is a big cyber attack happen. And in the Stuxnet and the Black Energy attack, such a thing is came from the APT groups. So Barry is a professional, cyber attacker attack such a power infrastructure. And also 2 years ago in the U.S. also some power infrastructure attacked by somebody we don't know who. It might be it is unknown. Somebody just for fun, we don't know that. Anyway, so power grid was attacked even in U.S. And the last year, as you know that in December, some burster backdoor supply chain attack. This is the target the U.S. government, including nuclear security facility. It is by some APT guy, and the problem was some vendor risk. So a lot of situation we can see that from the insider or APT or sometimes unknown, or somebody will target for the cybercrime, like by injecting ransomware. They want to earn the money, or just for fun can just hacker any guy just purchase some cyber attacks software. They can just target any some power infrastructures. So you can see that this chart, this figure, right? The energy sector has been become a prime target for cyber attack in recent year. It's not just extracting your credit card information. No, the attack type is similar, but the impact of the attack is very significant if the hacker target the energy system. The problem also is hidden behind this figure is most of cyber incidents are never reported publicly. So we don't know how many attacks happen in the near system, in power and energy system. So at least we know that the attacks surface is growing. So many people said even U.S. government, the Department of Energy, the challenge of the power system, critical infrastructure from the cyber attack is a very significant problem than other cyber attack. This is one example, and how the cyber attack in the power system or power and energy system is very complex and the problem. So this is an example of the security challenging in the distributed energy resources. So distributed energy resource include some renewable energy system, smart home charging system, battery system, any power device, controllable power device. We can just say DER, and you can see that DER can be aggregated by the third-party aggregator system, so they can try to provide some some market information and try to help the small DER system owner. And the vendor can access the DER system or device. Also DER owner can access such a device, right? And utility also can access device. So we have a lot of attack surface. So the major threat in this system is it is a multi-party involved system. So we don't know who will be the attacker, or attacker may just try to attack utility company or vendor company or third-party company. They try to finally target the DER, right? It will cause very the impact is very large. You can see that, right? And another attack is, as I mentioned, sophisticated attacker like APT or insider is very hard to detect. So it is another challenging. The other one is, DER devices, solar system or charging system are exposed to public, right? Another also, such is the inside network, we can call the operational technology network case is hard to, they all try to use the embedded system and a very lightweight network. So attacker is easy to hack such an OT device and network. So they are major threat, not like some information or technology side cyber attack. They just try to extract the data or change the data, but the attack targeting some DER are very different and very challenging. So yeah, right. Strong network security will very helpful, but it is not enough. As you can see that, right? So we need to build some cooperative, some security ecosystem. The vendor, owner, utility, and they work together to solve this problem. So let's look at some security research approach, for the PES system. I'm not gonna touching about some network security very detail. Just try to explain some additional thing or some grid rule or some focus I'm working on. Okay, so if you have a interesting in the cybersecurity for power and energy system, or somebody just can call smart grid, right? You need to know some standard and rule. Standard and grid rule might be different. In Korea, it'll be the governed by that utility, and the United States are different. At least if you are targeting some specific nation and the power grid, so you better need to not learn such a standard and rule. For example, IEC 61850 standard is about communication network and system for substation. Another one, the 1547 is about the standard for the interconnection and interoperability of the distributed energy resources, right? So this is the map of the adopting the IEEE 1540 2018. You can see that some states they adopt, and for example, BC by January 1st, 2020, they any devices who want to the distribute energy resource device should follow this rule, the regulation. Another one is a California rule. Any smart inverter, solar solar system or wind turbine system needs such a smart inverter. Need to follow. Somebody who the company want to sell this inverter, they need to follow California rule. In the California area, and they also provide a security level and some protocols as well. So they need to follow at least such a requirement, right? Also, some security standard are also available for power system control operation or smart grid, or they also provide such a security standard as well. Also, NIST or Department of Homeland Security, they also provide some security framework. It's not mandatory, but you need to follow such a framework, and such an institution can check whether you follow or not. Okay, let's look at some example. The first one is about blockchain cooperative trust ecosystem research work. Yeah, I also you guys are also interesting, and many people are working on. I know that. So most of application may be about the P2P energy transaction, right? Also, also you guys can use the blockchain system for the supply chain asset management. For example, software installed in the smart grid. How can you manage it? Their integrity and security. Blockchain is also good in a platform. Monitoring demand side management, decentralization control, such a thing. Network security also available. We can use it for, even in one of the project, we're gonna use the blockchain for solar farm system security. But still, there are some challenging issue, the performance improvement and security improvements still require. So how to, so about scalability issue and reducing latency issue and such a thing, or some privacy issue are remaining some topic to fully utilize blockchain in the power system. Also, as you know that some big data, yeah, and the cloud system, AI system, data science are commonly studied, right? So this figure shows the IBM big data platform for smart grid. GE, they have on some platform. Some big company they also provides such a big data platform. So we can use such a platform for the many purpose in the smart grids side. Still, there are still some barriers like high cost and the data management issue, and still, workforce is very short. It's hard to find, such a people who can use it or develop it. And some security point of view, data security is a big challenging, right? Data privacy issue, integrity, data authentication, some challenging. AI also, many people also study the use of AI, right? So we can see that there are lots of AI application even in the power and energy system. And for security purpose, AI can be used for attack detection and mitigation. Many people use it and develop it. So one project I did last year is about cloud-based battery system monitoring. So using the data, we can detect some attack happen, or whether it is about the hardware fault, or is about the sensor fault, or is about communication failure. Using the AI, we can classify such an attack as well. But still, algorithm itself or AI itself, we have some, we need to advance such an AI algorithm as well. As you studied AI reasoning, AI security, privacy, distributed AI, or self-supervised learning, such a, some AI related, pure research also can improve the, cyber system research in power and energy system. Third example is about some approach that we consider the power and energy system is industry control system. So it is about industry control system focused, especially MITRE attack model for ICS is about cyber kill chain method. This is very good for detecting sophisticated attacker like APT group. So we can just detect early before the actual breach occur, and we can neutralize such a sophisticated cyber attack, right? Just we have, for example, MITRE attack for ICS model is given here. So it has 12 stages. each stage, then the defender can make some how to detect method, how to defend the method. So if and for example, so a defender detects some attack in the stage 7, then the final before the attacker reaches the impact stage, they can stop, right? So such a thing we can also trace the or APT guys behavior by following the such a step. Also, our team also try to use cyber keychain method to detect some firmware attack in the DR system. So we can make some some defend detection and defense method by following such as cyber kill chain method. So mostly industry uses this method, for example, travels. But still some issue, there are still issue in the current work is it is less dynamic and do not consider imperfect information, such as a new vulnerability or unobserved attack or information leakage by malicious inside. Case, it is harder to use this one. So survival strategy should be proactive and evolve to maintain some critical capability in this approach. At least this is very good for the detecting the APT style attack. Another trend in the cybersecurity framework is zero trust security. It's for the operational technology. This zero, as you know that zero trust security concept was proposed by the NIST in 2013. So no network related entry can be trusted. For example, data, device, application, and system. So this system and device keep try to verify identity, activity, and access. So they don't trust even it is authorized from the authorized command from the authorized server, but they keep try to verify such a command. So now the security paradigm has been shifted from the network-centric perimeter-based defense to the user, asset, and resource-centric. It is very good for the utility operational technology system. The benefit of use of this one, we can detect inside, we can protect some inside attack. So some example, if you are interested in every also provide some zero trust security for utility OT cybersecurity. Okay, last example is a quantum security. So as you know that quantum computing is a game-changing technology which will push the boundary of the cybersecurity and the cryptography. So current smart grid network is actually exposed to the danger of the quantum attack if is possible. So this is one example. My DER system example, you can see that some network protocol and some security method, right? So SEP2 use RSA, TLS, they are vulnerable, and DMP or other protocol used in the this system or encryption method and vulnerable to the quantum attack. We could observe that. But also, quantum computing attack is evolving, not just RSA. They can be the evolved. So we need to also prepare. We need to study the quantum computing method theory so we can defend in advance. So there are methods, the quantum network security, the QKD, and quantum key distribution, or quantum post-quantum cryptography method we can develop to prepare for some quantum attacks. Okay, that's the conclusion. So we know that advanced CPS will significantly advance PES. Security is a big threat, and it is a shared response. We need to work together to solve this problem. And the security requirement of PS are different, not like some the IoT security or some information technology security. So hopefully we can build some cooperative zero trust security ecosystem together. Also, new engineering program needed to be discussed and engage students to bridge the gap between ES and so information and communication technology so works, and we need to develop cybersecurity workforce. Thank you. So if you have any question, just let me know, or you can email me so I can reply your question. Thank you.